Hello everyone. Let's deep dive into the semantic segmentation. So what is semantic segmentation? Semantic segmentation plays a vital role in the field of computer vision and getting a lot of attention due to deep learning techniques providing high level of accuracy for image analysis. Deep learning is one of the most effective approach to semantic segmentation, which involves training a neural network to learn complex relationships between pixels and their corresponding class labels. Deep learning has proven to be particularly effective for semantic segmentation because it is able to learn rich feature representations directly from raw pixels data, and it is able to handle large amounts of data and complex input distributions. Image segmentation can be defined as the partitioning of an image into distinct regions or categories, with each region containing pixels with similar attributes and each pixel in an image being allocated to one of these categories. So the goal of semantic segmentation is to train a model which can look at the image of multiple objects and infer semantic information from the images to detect and recognize individual objects present in the image. Semantic segmentation is a computer vision technique used to understand what is in a given image at a pixel level. Semantic image segmentation is a task to classify each pixel in an image from a predefined set of classes. So you can say that semantic segmentation is the classification at pixel level. For instance, in an image with multiple objects, we want to know which pixel belong to which object. So in semantic segmentation, you will classify each pixel of an image to a specific class. So here you can see the input image. In this input image, there is a person, purse, grass, sidewalk, buildings, etc. And you can see the semantic label for person is 1. Semantic label for purse is 2. For grass or plants, the semantic label is 3. For sidewalk, semantic label is 4. For building, semantic label is 5. So the goal is to take an input image and generate a segmentation map containing the predicted class IDs corresponding to all the pixels. So you can see the person region is represented by semantic label 1. Here you can see. And person region is represented by semantic label 2. Here you can see the region. Similarly, grass and plant region is represented with label 3. Sidewalk region is represented with semantic label 4. And building region is represented with semantic label 5. One of the most effective approaches to semantic segmentation is deep learning, which involves training a neural network to learn complex relationships between pixels and their corresponding class labels. Deep learning has proven to be particularly effective for semantic segmentation because it is able to learn rich feature representations directly from raw pixel data, and it is able to handle large amounts of data and complex input distributions. There are several types of neural networks that can be used for semantic segmentation, including convolutional neural networks and encoder-decoder architectures. There are several challenges and considerations when working with semantic segmentation using deep learning. One of the main challenges is the need of large amount of annotated data, which can be time consuming and expensive to collect and label. Another challenge is the need to balance the trade-off between precision and recall, as well as the need to handle a class imbalance and class overlap. Finally, it is important to consider the computational and memory requirements of the chosen neural network architecture, as well as the hardware and software infrastructure needed to train and deploy the model. Overall, semantic segmentation is a challenging but rewarding task that can have a wide range of applications. So by leveraging the power of deep learning, it is possible to achieve state-of-the-art results on a variety of semantic segmentation tasks, and to unlock the full potential of the computer vision for solving real-world problems. So the deep learning model takes an input image and outputs segmentation map of the individual objects detected in the image. In the input image, you can see the persons, bicycles, and also there is a background in the input image. And in the output segmentation map, you can see the persons, bicycles, and background with different colors. So when you feed an input image to the deep learning model, it will predict the output segmentation map of the image. Semantic segmentation follows the encoder-decoder architecture. Let's see what is encoder and decoder architecture. So what is the job of the encoder in semantic segmentation? The encoder is usually a convolutional neural network which extracts meaningful feature map from an input image, and also it increases the number of channels in each step, and downsample the image means it reduces the height and width of the image. And what is the job of the decoder in the semantic segmentation? The decoder upsamples the feature maps and decreases the number of channels and outputs a segmentation map, which is a region of pixels. So here you can see the example encoder-decoder architecture. Encoder downsample the input image and decoder upsample the input features to output the segmentation map of the input image. So there are different layers: convolutional layers, batch normalization, ReLU, pooling, upsampling, and softmax layers. See you in the next lecture.